Hello everyone, welcome to the new and exciting episode of Solutions for a Sustainable World. This is the second part of our series dedicated to solutions, and in this episode we will particularly explore how we can change our production and consumption practices to feed ourselves sustainably within planetary boundaries. For this episode, I drew a lot of inspiration from two primary sources of data and additional information. Below, the statistical database of the FAO, Food and Agriculture Organization, provides many very explicit charts, and we will see some of them in just a moment. Additionally, Creating a Sustainable Food Future is a comprehensive report published by the World Resources Institute in collaboration with several research centers, including CIRAD, the French Agricultural Research Center for International Development in France, and the UNDP, United Nations Development Programme. It's a very comprehensive 500-page report that covers most of the aspects we are about to discover now. And before diving into the details of the solutions, I would like to quickly give a brief overview with a few graphs of the problems we are facing. On one hand, agriculture occupies 5 billion hectares, which is equivalent to approximately 1/3 of the Earth's total land surface and covers half of the habitable land area on Earth, a significant portion of the total. Crops are represented in yellow and livestock in red. This is a considerable area, and we don't have much room for maneuver. Agriculture indeed consumes a very significant amount of water, nearly 92% of the world's water consumption. Agriculture still consumes a significant amount of fertilizers and pesticides, although, as shown in this graph, usage has plateaued for about 10 years now. With a rapidly increasing population and substantial lifestyle changes, we are facing rising food needs. As shown in this graph, you can see the total number of calories approximately needed to feed humanity in the year 2010. The projected calorie requirement for 2050, and the difference between the two, is what the authors call the food gap, the additional food that will need to be produced to feed everyone. So this is not going to happen with a constant surface area. If we stick to exactly the same production methods as before, it means we will roughly need an additional 600 million hectares of land, approximately about 200 for crops, and about 400 for livestock. This is what we call this time the land gap. So we have a food problem that will create a land problem. And to get an idea of what these 600 million represent, if you remember the previous episode on the regeneration of biodiversity and the biosphere, and to be able to give space back to ecosystems, we need to free up 800 million hectares. So if we do both, it starts to add up. That is to say, 800 million hectares, the area of Australia, and 600 million hectares, the combined area of India and Argentina. So we are really talking about very significant changes. The sector faces other problems. The agricultural sector indeed accounts for 25% of greenhouse gases, 14% due to the very nature of agricultural production, ranging from soil fertilization, methane emitted by rivers, to methane emitted by cattle and other ruminants. Then there's the 10% that comes from deforestation for planting purposes, particularly in Brazil, Africa, and Indonesia. All these problems are exacerbated by the fact that climate change is already having very perceptible effects and is obviously having an impact on agricultural production. Here is the projected map of what could potentially happen in the year 2050 with a 3-degree increase. In red, you have yields that drop significantly by half, and in green, yields that rise up to a substantial 100%. We can clearly see that some parts of the world will benefit while others will lose out, and overall this will necessitate a massive restructuring of global agriculture, particularly because we won't be able to plant the same crops in the same places. Given all these issues, the World Resource Institute, in their comprehensive report, takes stock of the possible solutions, or at least a large part of the possible solutions, and proposes a wide range of option menus, as they call them, to address these three challenges simultaneously. They explore how we can, in the next 3 decades, since we are no longer in 2010, move forward to both feed the population, reduce land use, and cut carbon emissions. This involves significantly increasing the amount of food produced on the same or even reduced land area, and effectively reducing the demand for products that require the most land or emit the most CO2 in a sustainable manner. So we are following this well thought out strategy. Now the important question is, how do we get past the year 2050 and ensure that we can provide enough food for everyone on the planet? Here it's the same kind of graph, but it shows how we can reduce and avoid having to plant an additional 600 million hectares in the next 30 years. But we'll see later it's even about reducing by 800 million. And then the third point is how we gradually reduce greenhouse gas emissions from the sector by acting on all the parameters in a systematic manner. It's a very, very comprehensive report that I highly recommend you check out if you're interested. I will just briefly go over it during the episode, touching on a few key points to give us a better idea of the major trends and mechanisms they have considered. So here on this particular slide is a comprehensive summary of all the key points that we are going to cover in detail now. And then I'll add a few more additional other ideas that come from the literature. But we are indeed actually measuring the total agricultural land. There it's the additional 600 million hectares imposed by the fact that we will be more numerous. And then each of these blocks represents the possible reduction through feasible measures. There are 3 main blocks of measures. We can reduce demand, so let's see how. There is a second block, which is that we can increase production and yield significantly. And then a third one, which has very little impact on land, which is quite normal since it concerns the marine environment. But it is very important to be able to provide enough high-quality calories and good quality food in the next 30 years. To add other additional and significant elements to the World Resource Institute, I found several very interesting and detailed articles. This one, which was published 2 years ago and fundamentally makes the same observation, still has roughly the same figures. We will need to reduce, and we will see how, the waste of products. We will need to reduce the share of animal calories and increase yields. But it brings a dimension that the World Resource Institute does not mention, which is the increase in agricultural product exchanges and the reduction of trade barriers. We will see shortly why this is important. And a second article, which is somewhat complementary and was published in the same year, also discusses things that are in good taste. It also indicates that today's global agricultural production is not compatible with planetary boundaries, and that to address this, a whole range of actions is needed, including the spatial redistribution of cultivated lands. This is the element we will add in relation to what the World Resource Institute says. This sets the stage. Now, I invite you to explore the different approaches and methods proposed to reduce demand and increase production in both terrestrial and marine environments in various ways. To reduce demand, there are essentially 3 major areas in total. We need to significantly reduce losses and waste and change our diet. This is by far the system that has the most impact. That also means developing new foods. In the report by the World Resource Institute, there are 2 other points that I won't address directly. Stopping biofuels and accelerating the demographic transition. And now I invite you to take a look at what we can do about waste. It's quite incredible. In the figure given in the report, they say that approximately 24% of the amount of food produced is not consumed, as shown in the figure. So it is actually distributed all along the chain between production and consumption, and each time we lose a little bit, and in total actually a quarter of the food is lost. which in terms of greenhouse gas emissions means that the water, land, fertilizers, everything we've put into producing this food is indeed wasted, and on top of that it emits greenhouse gases. How much does it emit? With these figures, it's equivalent to a third country, meaning the third largest polluter in the world after China and the United States. It's really enormous. We have an incredible margin for maneuver on something that costs nothing and doesn't change our habits, except for not wasting. That's a lever, it's the first lever, and we understand why. So these figures are all the more incredible because last year's UNEP report indicates that, in fact, we were actually wrong in our estimates and the waste is indeed twice as much as expected. So I haven't redone the calculations and I'm not sure if it's linear. Therefore, I can't tell you if waste has become the second largest producer of greenhouse gases. But in any case, it's an exceptional aspect. It's an exceptional margin for maneuver. It's distributed there as well, all along the production chain. This concerns all countries, whether they are from the north or the south, and we can see on this graph, it's the representation. Each point is indeed a country, based on the wealth of the country. There are countries with a GDP per capita of $20,000 and others with around $120,000. So we find our friend from Luxembourg there. This is the average amount of food that is wasted per household each year. It ranges from approximately 20 to 200 kilos per year per individual, which is just incredibly enormous. What is interesting in this graph is that actually between 20 and 200, you can see that among countries at the same stage of development, or at least with the same economic income, the variation is very, very significant. It can range from 20 to 200, it can range from 20 to 140, etc. So it is not directly related to the level of advancement of a country or to its internal wealth. It seems that it is related to other factors. So it's probably interesting because it means we might be able to draw inspiration from those who do less to help reduce among those who do more. Nevertheless, the main principles to help reduce waste are, of course, to try to be as proactive as possible in various ways and methods in our daily lives and routines to minimize waste. In other words, if we buy less, it's much better because we don't have to deal with it afterwards and it costs households less. If we eat less, if we compost locally, etc. The further we go down the chain of degradation, the more harmful it becomes. And therefore, the more we have an interest in acting very early. And in the end, we can evidently see that we could definitely continue this graph and conclude that the most preferable option is not to produce at all. So that's the idea. In essence, producing less is where we will really save significantly because we will be able to gain efficiency at every single step. So the report lists a whole bunch of possible options which are included here that I obviously won't comment on. In red, it's the one he details in the report. I found it interesting to say a word about the one I added here in blue because it directly affects us as consumers. So he does mention reducing portions. It's obvious if there's less on the plate we can get seconds, but obviously we waste less. In fact, ultimately we waste less. It's quite simple, but I think there are still many places where it would be interesting to implement. Facilitating the learning of cooking. I don't know if there are many countries that teach their citizens how to cook. But it would be interesting because it's a good way to learn to do different things. Because it is also related to the fact that education on this subject is obviously the most important lever. We are not all necessarily aware that we can do something very important almost without doing anything and even while saving money. So this is a direct lever that can be quickly integrated into campaigns, for example, at the school level, such as elementary and high schools. There is another one that concerns standards in terms of eating products that are imperfect or making products that are imperfect sellable. Here, we're talking about representation. A perfectly round yellow apple, very appealing. Even with a small flaw, it's still perfectly edible. And yet, how much food do we waste? So, I won't go into more detail, and there are many players who have positioned themselves in this market to rightfully try to contribute, and that's really a very interesting aspect. Now let's move on to the second part, which is about changing our diet specifically. So what does changing our diet mean in practical terms? It means that here on this graph you can see the blue line, which represents the amount of protein we should eat per day. This graph clearly shows the recommended daily protein intake, helping us understand how much protein is necessary for our diet. Each block represents what people actually eat. In India they are just a little bit slightly above. In Asia they are significantly higher. And then China, Europe, Brazil and the United States, we see that they are really much higher, almost double for North America. In green we see plant proteins, and in red animal proteins. What does this tell us? It shows that in most countries around the world, we consume too much protein overall, especially animal proteins. So it's not about everyone becoming vegetarian. But if we could, in fact, reduce some of this amount of animal protein, which is in any case actually excessive, we would not only have better health, but it would be beneficial for everyone. So this is a way of presenting things that I find quite interesting. So why are animal proteins and beef in particular important as a lever for the environment? In this graph, without representing, you can see that there are indeed very different things. From left to right you have a number of various commodities, and all the way to the right you will find the beef and the sheep. What does that actually represent? In orange, it is the amount of greenhouse gases that is actually emitted. And in green, it's the amount of surface area needed to produce the same quantity of calories. Then other food sources. We can better understand why there is a critical issue surrounding livestock. It disproportionately consumes the most resources, especially land, and emits the most greenhouse gases. Indeed, this is a very significant issue. To summarize this in a single figure, beef represents approximately half of the land use and emissions associated with Americans' food, while it only provides about 3% of the calories. So we can clearly see that there is a significant imbalance here that we can definitely try to address. Another way to represent this time only considering greenhouse gases, is to say that beef is indeed 60 times more than, for example, tomatoes or corn. It gives an order of magnitude of the amount of greenhouse gases produced throughout the life cycle of the products. There is indeed a very clear difference between animal protein sources and plant protein sources. Moreover, the reduction of meat consumption is currently underway. This graph, which is from France, is shown here. What we see is that there was already a peak in meat consumption in the 80s, let's say a plateau, and since then there has been a steady reduction, even though it is not very significant for now. What is interesting is to see that there is not only a global reduction in the amount of meat eaten in France per capita, but also it is not the same type of meat that is being consumed. Overall, beef consumption is generally decreasing in favor of poultry and pork. And if we ask the students what they generally think, they are typically much more aware than previous generations. And according to the 2020 ReFed report, 73% of students have already reduced their consumption of meat and fish or wish to do so, and 11% have already switched to a vegetarian diet. 11% is a lot for France, or typically for those over 50, it's more around 2%. So young people are, generally speaking, 5 times more likely to be vegetarians, let's say, than seniors. So this might be something that's in progress. In any case, in the United States, the market for meat substitutes is significantly increasing at a rate of approximately 20% per annum, 28% per annum, 170% per annum, with a range of products that we wouldn't have imagined a few years ago, such as plant-based eggs or maybe milk or plant-based meat. These are new types of products that resemble meat-based products but are made from plants, so they have a completely different ecological footprint and will definitely satisfy consumers' tastes, meaning there is no need to change taste preferences. On the other hand, we drastically reduce the footprint. So this is something very popular in the United States. I have taken another example of a French company, Odontella, that is currently in the process of developing something I find quite fascinating and original in a couple of distinct and unique ways. On one hand, it's essentially a fish substitute, as they make plant-based smoked salmon there. And secondly, they don't do it with land-based plants, they do it with algae. And that's interesting because algae grow in the sea, and by definition, anything that grows in the sea doesn't take up land. So we have another way to substitute and reduce. So after looking at some of the possible ways, there are obviously many others to reduce the footprint of what we eat from a consumer's perspective. We can now see how we will be able to increase production on sometimes very significant scales. And there are also three major areas in the World Resource Institute report as well. The first is to increase livestock productivity. The second is to improve crop yields. And then the third one, which I actually won't talk about, is planting seeds more often. And I would like to add two very quick points. How could we possibly reallocate and redistribute some lands? And how can we cultivate other spaces? I found this figure very telling for understanding how to increase productivity in livestock farming. We often think of industrial production in our country, but why could we say something like that? Because we have in mind sometimes industrial productions at home, but for others, indeed, actually in the United States, Europe and Japan, all the points that are in green indicate protein production with a CO2 emission amount that falls within this range, which is indeed slightly less or even significantly less than what we saw on the previous graph, which is to say between 25 and 50 kilogram of CO2 emitted per kilogram of protein. Except in Africa or here between the border of India and Pakistan, if you are in dark red, you are at more than 1,000 kilograms of CO2. So 1 ton of CO2 emitted for 1 kilogram of meat produced. Okay? So it's just monstrous because it's 100 times more. So this gives us considerable room for improvement. And so we better understand why the authors emphasize that if these livestock, if there were other ways to cultivate, well, to raise them, especially as we see in Africa and Madagascar, we could indeed drastically reduce the footprint because such a quantity also means a lot of land is needed, hence a lot of water, many things that these regions are not necessarily well endowed with. So there is a question of rationalizing the whole system with two main mechanisms, and we will talk about them later. The first one is this: in order to increase productivity locally. And then a second point, obviously, is to consider that maybe we should export and stop producing or produce differently and less in places where it is not very well suited. What is true for meat is, of course, also true for milk. Between the most efficient milk production systems and the least efficient ones, there is a factor of 6. Producing 6 times more milk per hectare certainly doesn't require the same amount of land, so this increase in productivity is indeed a very interesting lever. What we said about livestock applies to crops, and we can see in this illustration from the FAO, Food and Agriculture Organization, that in 20 years, between 2000 and 2018, there was a 50% increase in food production for the same area. So, it's a notable increase in yields that has been continuous and linear since the 1960s. This is the increase in yield, i.e., the number of tons per hectare per year of a crop, in this case cereals. So we see that it's linear, which allows us to estimate where we might be in 2030, 2040, 2050. What the authors determine is that if we continue this steady linear progression of global yield, which takes into account all the places where production is very low as well, in various regions and areas, we will make considerable and significant efforts to achieve our goals, but we need to do a bit more or even significantly more than the rate indicated here. These are still important challenges. We will now look at some of the methods that are being studied or are in the process of being deployed to improve yields. An example here is agroforestry. Agroforestry is the practice of combining different plants to increase yields. Here is an example from Zambia, where since 2007, 2008, 2009 and 2010, the amount of maize produced each year has been measured, either grown alone or co-cultivated with a tree whose name I will spare you, which will therefore provide shade and nutrients, creating an ecological relationship between the two. And so we go from a factor of 1 to 3, and we see that year after year, the difference in yield is still very significant between doing it alone or doing it under the tree's vegetative cover. Here's a method for improving yields, especially in food crops. That's agroforestry. This is an example that has sparked a great deal of research into something much broader and more comprehensive that is now called agroecology. Agroecology, as defined by its founder, is the application of ecology to the study, design, development and management of sustainable agrosystems. I must admit that it is indeed a bit difficult to properly navigate because it is a comprehensive set of practices that fundamentally and essentially encompasses 6 distinct and different dimensions. There is a desire to promote the resilience of the system, and this resilience can be expressed in different ways, in various forms and through multiple approaches to ensure stability and robustness. Some practices will aim to minimize the use of inputs, such as pesticides or fertilizers, in various ways and methods to achieve this goal. The second will be to contribute to the local food system, so we are more on a social logic. The third is to promote ecological services. The fourth, promote genetic diversity, preserve natural resources, water, soil, biodiversity, and optimize and balance nutrient flows. These 6 dimensions are not independent and interact with each other in various ways, but it is clear that if we want to optimize how we contribute to the local system, we may not use the same practices as we would to optimize another dimension. This is represented in this graph by saying from agroecology there are many different practices such as various methods depending on what people want to do. This could involve developing local agriculture or boosting ecosystem services following the American model, or focusing on very precise optimization and technical performance for precision agriculture. So we're dealing with a concept that encompasses a huge number of different practices. To capture what agroecology is, according to the reports of INRA on the subject, it is a field of research, practices, and a movement. A field of research because if the term started in the late 90s, we can see that it developed immediately. This is evident from the number of global publications on the subject. In 2020, there were nearly 10,000 publications on the topic. It is a very active field of research. It is also a movement and practices in various forms. So I took another example from France as an illustration. So there is a community called Au Cœur des Sols that has decided to optimize these 3 components: planting without any soil tillage, maintaining a permanent soil cover, and cultivating diverse species in order to achieve better results. I called it participatory approach to transforming agricultural practices because one of the highlights of agroecological practices is that communities work together, share their practices, and try from one year to the next. Therefore, there is a research approach, participatory research, and a community of practice. So the aspect of practices and a movement really fits well with this, and it yields results that seem quite interesting. On the Au Cœur des Sols website, at the heart of soils, it mentions a reduction of 10 to 50% in greenhouse gases, 60% in fuel consumption, and 90% in water erosion. So a reduced amount of water, a smaller number of greenhouse gases, a reduced amount of fuel used, fewer phytosanitary products, particularly against insects and mold, and then an increase of 50 to 400% in carbon stored in the soil, more earthworms, etc. So there is something along those lines, people settling in a particular terroir, because it will depend on where they are, the conditions of each terroir. It's not the same soil, it's not the same sunlight, it's not the same practices, etc. And who will work together to create a community that exchanges practices to maximize the different dimensions we have looked at, the yields, and by trying to optimize with respect to the ecological footprint. And this is something that is global, as there are agroecological communities in every country. Another possible way to improve yields is to do what we have done for some major crops for decades, but to do it with what are called orphan crops. These orphan crops, which are often overlooked and underutilized, occupy 300 million hectares and include important staples such as sorghum, millet, cassava, sweet potato, etc. These are plants that have not benefited from agronomic improvement or not enough, and on which there is a lot of room for maneuver. So if we are able to double, quadruple or sextuple the yield of these crops, it's always more food on those 300 million hectares, which means fewer hectares needed. On the other hand, it's always the same story. So that's one way to do it. Now, I've chosen a radically different method for you, which has been in progress in the Netherlands for a few years. The Netherlands have developed a very, very technical method of agriculture. They have planted greenhouses everywhere, which are heated by geothermal energy, sometimes by electricity, with calculated drip irrigation and UV lights to grow in winter. Finally, they are using an extremely technical method, and within a decade they have become the second largest exporter of fruits and vegetables in the world, after the Americans, by reducing water, pesticides and chemical fertilizers by 90%. So we are practically on the opposite paradigm. In the case of agroecology, it's about working according to the rules of nature, so to speak, and trying to see how, depending on each territory, we can optimize open field crops. In this case, however, the technical approach is to free ourselves in various ways as much as possible from the limitations and constraints of nature, to industrialize processes and methods while using the least amount of inputs and causing the least disruption to the system itself in the most efficient manner possible. Two radically different ways to explore how to effectively improve yields in order to meet the challenges. Another slide on what is called Agriculture 4.0, which is how we use new technologies in the field this time to try to be as precise as possible. This is precision agriculture in terms of treatment. So here in this particular representation, we have a field with a drone or perhaps a surveillance camera that would continuously monitor the current state of the field based on the various lights it detects in different spectra that are not visible spectra. He can see water deficiencies, he can see plants suffering because they are being attacked, such as by pests, etc. And at that very moment, it sends information to the farmer or to a drone system that will deliver water or a phytosanitary product, but only where it is precisely needed. In other words, it's something that will limit inputs and enable us to manage large areas with the utmost care. So that's the promise we're making. Of this type of agriculture. Finally, on this slide, I present to you agrivoltaics, which originated in Japan, where there is very little land and they have tried to optimize space to the maximum. It most likely originates from a reflection on the disagreement of use that can potentially exist between various. You have a hectare, what do you do with it? Do you perhaps grow something? Do you install solar panels? I think we all have in mind those absurd solar farms that indeed take up a lot of space and sterilize the area. There, you just need to put it on stilts, and actually we have both on the same surface, since the sun will actually provide electricity. The solar panel will provide shade efficiently and effectively, can even allow for rainwater harvesting effectively, and you can grow plants or forage for livestock sustainably and efficiently underneath. So there is indeed a rather attractive combination, and agrivoltaics is now developing quite rapidly. So now we are going to cover another topic that is not in the report by the World Resource Institute, and that actually talks about a subject that was indeed quite significantly under-researched before. It is indeed very recent. It's an article from last month. It is the first global study that identifies priority areas for land relocation to maximize environmental benefits. So here we are following a logic quite different from what we've done so far. It's not about optimizing yields in a given place. It's about acknowledging that cows emit 100 times more CO2 in a certain area. Let's stop raising cows there and instead raise them where we can, where the yields are good. And in the places where we can't raise cows, let's do something else that is suitable for that area. How can we in each region try to optimize the corresponding crops? The calculations, which are all based on a very theoretical model, suggest the possibility of a CO2 reduction equivalent to 20 years of our emissions, which is enormous. Between now and 2050, or between now and 2100, if we are able to gain 20 years, it gives us more time to do everything else, given the race against the clock we are engaged in. So to get a somewhat visual idea of what this type of work means, they have a somewhat accurate representation of the world. They show crops in green. They have done similar work for livestock, but it has not been published yet. The darker the green, the higher the proportion of the territory covered by crops. It goes up to 100% for the darkest green. This is the current global map of agriculture, and if we optimize the crops, it would currently look like this. So I'll definitely give it back to you today or tomorrow. If you look at India or China, it's quite telling, especially in terms of economic growth and development. So on paper, it's always definitely easier with a pen than in real life. On paper, it indeed looks great. That's why he publishes in Nature. It is obviously, clearly, finally the case. The authors are not naive at all. Completely overhauling the system is not possible in any way. And if we consider that India or China will indeed stop producing because much more will be produced in Africa than in the United States, we can see that it doesn't make sense. They made two significantly different calculations. What I am showing you across countries is really about optimizing on a global level, as if nations did not exist. And then they did another one which is more interesting, which is to ask, if we did it in the same country, with the same jurisdiction, with the same administration, are we capable of doing something of that order? And what it shows is that if we reallocated just 25% of the land within a single country, we would already achieve half of the significant benefits of the optimal solution, which is already a lot. This means that regardless of the proportion of reallocation we might consider in the next 30 years or so, each of these reallocations would have a substantial impact. This is a relatively simple way, at least on paper, to increase yields by producing more in one place and planting the crop that best matches the location. So the corollary of this is that we would indeed consequently need to exchange even more products from country to country or from continent to continent, which is already in fact the case. And that's not necessarily a problem because, contrary to popular belief, eating local has very little impact on greenhouse gas production. Going back to the table we saw earlier, where beef is still in 8 parades, then down to apples, as we can see, and to nuts which are even neutral or negative. If we look at this graph by color, we can see from each color where the greenhouse gases come from and at what point in the production cycle we can allocate the greenhouse gases. It comes from deforestation, yes, indeed, a lot, especially in Brazil. It comes from farm work, from what we fed the animals and so on, etc. Transportation is the red part. For beef, when you have 60 kilo of CO2 emitted for 1 kilo of meat, it's clear that the red part isn't necessarily the most important. All right, and that's practically the case everywhere, except here with the pork, where it's very important, and with the shrimp, where it's relatively significant. For the rest, we see it's not the most significant part, so we can envision a system where we play on the reallocation of land within a country, especially within a region, where we increase the transport of materials, increasing the related CO2 emissions, and yet we will come out ahead because, for example, beef, instead of producing 60, will produce no more than 30, or instead of producing 1,000, will produce no more than 20. So there's definitely something indeed along those lines that makes eating local or not, in any case, not a matter of transportation. So That doesn't mean we shouldn't eat local at all. That's not what I'm saying in any way. And I'll give an opposite example right away, which is another very interesting and indeed fascinating trend, which is to cultivate areas that are not traditionally used for farming at all. It's the development of urban agriculture. If this topic interests you, Eric Duchemin at the University of Montreal, Canada, is a great specialist on the matter. We've been hearing about this for decades. And he is very knowledgeable on the subject. And so in all corners of the world, whether in Africa or France, we can have a production system that operates on land not dedicated to agriculture. So it's a way, in quotes, to essentially create additional hectares of production. These are ultra-short production cycles, so we are directly next to the consumer, which massively reduces a lot of things. And then it's a source of social connection, and thus it's a source of well-being for the population, because people really enjoy being able to, especially if they are community gardens, and it allows for environmental education, which is always a challenge in urban areas. So it presents many benefits in various ways. If it's not present in the World Resource Institute, it's probably because the contribution of this type of solution to the whole is quite limited, because we can well imagine that we are not going to make millions of hectares in the city. We can do some, it's a small portion, but it has other advantages. When we talk about increasing production, we often mean increasing livestock or crop production, but it also concerns the maritime domain. And there we have very different issues. On one hand, fishing, as you may recall from the problem space, has indeed reached and often far exceeded the maximum possible significantly. In orange, you have the number of fisheries that are considered overfished. So we are now at nearly 40%. In blue, those that are not yet overfished, but the white line describes the difference between those that are not yet fully fished and those that are already fully fished. Needless to say, there is very little room for maneuver. That was in 2015, and I don't see how it could have improved since then. We cannot expect much of an increase in animal protein production from traditional fishing, especially since it is currently facing a multitude of significant and complex problems that are difficult to resolve in the short term. In this paper, there is notably a very important and extremely significant piece of information. It has been shown that deep-sea trawling, a technique using very large nets to scrape the ocean floor, takes everything in its path and leaves behind a lifeless desert, including corals that are several hundred years old. To give you an idea, a 747 could fit in one of these trawls. If we want to get an idea of what that means, it's underwater, so it's not visible. But if it were on land, it would indeed mean that there would be hunters who had invented a hunting technique to catch a few deer. They would launch planes in order to successfully and effectively clear the dense and vast forest. That's exactly what we're doing, but it's underwater, so it goes unnoticed. Deep-sea trawling is actually responsible for a gigaton of carbon per year, which is approximately as much as the global aviation sector. Why? Because when trawls pass and repass repeatedly, they resuspend all the sediments, which are precisely the places where carbon starts to settle. This facilitates its redissolution in the water column, and a small part eventually escapes redeposition. And since trawls pass one after another, we have a problem. Not only do the boats consume a huge amount of fuel to fish farther and farther, but this paper demonstrates a much more significant and systemic effect. All this to say that overfishing, and particularly deep-sea trawling, should indeed be drastically reduced, if not stopped, if we want to have sustainable fisheries. We will need to significantly and efficiently increase aquaculture to produce the corresponding proteins. I assume that we have already done everything else. In any case, we have done everything we could to try to reduce. We eat less fish, but still we do eat some. In any case, there are people who eat it. So, what do we do to produce it? It is expected that in the coming years, there will be fewer and fewer fish caught at sea. I am not talking about subsistence fishing and small fishermen. I am talking about very, very large boats that scrape the bottom. And at that point, we need to develop aquaculture. However, this brings another problem, because aquaculture, when you have a concentration of fish, it means issues of eutrophication sometimes, and it especially means problems with feeding them. Today, the fish produced in aquaculture in various regions are often fed with pellets made from fish caught through what is called reduction fishing, which means very small fish like sprats are mixed together, processed, turned into a fine mash, and then subsequently given carefully to the aquaculture fish. Clearly, significantly increasing fish aquaculture means changing the way they are fed, and there is a lot of research currently ongoing on how to make aquaculture more sustainable. One idea that is currently being explored and deployed to feed farmed fish involves producing food for farmed fish from insects or insect powder. Insects are animals that are extremely efficient, with a very efficient metabolism, which means they require very little food to produce insect proteins. They have a metabolism, an energy conversion rate that is indeed very efficient. So in warehouses with a few plants, we produce some insects, which are then ground up and turned into pellets that can be used to feed fish. So this is a way of providing fish with high quality protein without having, or at least trying to minimize, the effects on the marine environment. So this can be a way to improve aquaculture in various ways, and then I wanted to briefly finish on aquaculture by mentioning something else, which is that we often talk about fish, we often think of salmon, but if you look at the small orange bars here, they represent algae. We find that since 1990, there has been a continuous increase in the amount of algae produced in aquaculture. It's exactly like on land. It is definitely much easier and much more interesting to produce plants than to produce animals, because there is indeed no need for energy conversion. So we have fewer losses along the way, if you will, and these products are extremely good for your health. Algae have a significant advantage over terrestrial plants in that they do not take up a lot of land, such as hectares, and therefore, so this is also an additional way to gain those precious hectares. Mushrooms would be the same, because mushrooms can be cultivated, for example, in tunnels, as they don't need sunlight. So there are definitely other foods, such as those that do not depend on the earth, and that can be a way, once again, to increase the production of the system. And finally, I will present a few ideas very briefly, which are rather speculative at this point, but they are potentially interesting avenues to try, at least marginally, to produce in a different way. So I will quickly cover three things. Urban farms, we have an example here, cultured meats and synthetic food. Urban farms, which are innovative agricultural systems, mean that you can cultivate crops and plants in unconventional spaces such as warehouses or industrial buildings. So it's the Dutch model, if you will, but taken to the extreme, because here you are in buildings and under artificial light, and you can control everything, the water, the inputs, etc. The productivity of this type of... The impact on cultivation is considerable, absolutely considerable, because you avoid losses, as there are very, very few insects. There are obviously no insects in the system. You perfectly control what you put in, etc. It also consumes an enormous amount of energy, of course, and so knowing which of the two is more interesting, is it to produce food locally close to cities, or on the contrary, is it going to take up too much energy? We'll have to wait and see what will come out of this, but it's about exploring and experimenting in different places, particularly in Europe and Japan. The second thing I wanted to introduce to you is artificial meat that is cultivated, that I find fascinating and innovative. And here we also have a detailed cost-benefit analysis that on paper is indeed very interesting. Because if we compare meat from a traditionally farmed animal with meat produced in a lab, we see differences in water consumption, greenhouse gas emissions, and especially in the amount of land used, which is very significant. So this little graph is slightly outdated, and at that specific time there was a factor of approximately 10 in the production cost, which by design completely and utterly limits the use of this type of thing, because if it's 10 times more expensive, absolutely no one is going to buy it. However, it turns out that this is developing very rapidly. Production costs are decreasing significantly, and it is not impossible that in the future we will have cultured meat on our plates, or at least on the plates of those who wish to eat it. And finally, now we're really entering the realm of science fiction. There's another idea, which is to produce protein in a completely synthetic way, that is using electricity, water and air, which is a novel and futuristic concept that could potentially transform the production of protein. That is CO2, indeed making food without any agriculture at all. What this Finnish startup has shown is that it is possible to produce a type of animal feed from energy, which in their case comes from renewable energy. This feed is obviously not for us, but it could be used, for example, to feed farmed fish, etc. We are indeed in the realm of speculative analysis here, but it's interesting to see a completely different entry point, because we are no longer in a system where we rely heavily and directly on the sun to produce something. We are entering a logic where we successfully manage to produce something that allows us to start a food chain from chemistry and energy. So I will stop here for now with the overview of what I have found and what seems interesting to share regarding the solutions at this point in time. It is obviously largely inspired by this report, which I recommend if you are interested in these topics. And just to summarize, we can say that fundamentally, in essence, the challenge we face is not only to feed everyone without having to plant an additional 600 million hectares, but also to reduce by a total of approximately 800 million hectares to make room for ecosystems that need to regenerate. In this report and in other corresponding studies, there are a whole bunch of various potential possible solutions to implement. Obviously, it's the combination of everything. Here we find an idea that we've already experimented with several times, because we will reduce losses, because we will change the way we eat, because we will reduce biofuels and so on. We will achieve this goal. We really need to work on all fronts to be able to feed humanity peacefully by 2050 while actually staying within planetary boundaries.